Okay, going to be working 10.3, the dot product. And going to be starting with number 1, which I'll do 3 of these and then let you do the other 3. Number 1, part A, says you have a vector A dotted with a vector B and then dotted with a vector C, and it's asking you whether or not this has any meaning at all. So if you take a vector and dot it with a vector, you're going to get a number, which we'll say is a scalar. And then you're going to dot that with a vector. And the problem is that this dot is, a dot product, not a multiplication. So of course you can scale a vector if this were standard scalar multiplication, but it's a dot product. In order to do a dot product, we have to have 2 vectors. So we have a vector here and a number here. This operation is not possible. So that expression here makes no sense. That's what they're asking. Does the operation make sense? Is it doable? Let me look at B. So you have A dot B and then C like this. So notice that it's implied that there's multiplication here and it's not a dot. So it's implied that that's scalar multiplication. So let's see, we multiply these 2 together with the dot product and that's going to give us a scalar. And then we're going to take that scalar and we are going to multiply it times a vector C. So we're going to scale a vector. And so this does have meaning. This would be possible for us to compute. Let me give you an example next to this. The scalar, let's say you dot 2 vectors together, you get, let's say, the number 3. And then I say dot 3 with the vector 2, 4. This is not possible. Okay, so that's what this is saying. Here, let's say we dot 2 vectors together and we get 3, and then we scalar multiplication or scalar multiply 3 times this vector. That we can do. We just distribute that 3 through and we get the vector 6, 12. So very important to understand the difference between these 2 problems, A and B, is the dot product here versus scalar multiplication, which is implied because there's not a dot there. All right, and then we'll take a look at, we'll just do one more. Let me do F. So for F, we have the magnitude of a vector A dotted with the vector B plus the vector C. So you can see here again, the magnitude of a vector is going to be a number. So this is a scalar. And then we're dotting it with the sum of 2 vectors. When you add 2 vectors together, you get a new vector. I'll call it V. And so this is kind of like part A. You have a scalar, you're trying to dot it with a vector. That's not possible. So this would not make any sense. All right, I'll let you do the others. Now let's look at number 2. So we're going to find some dot products here. They give you a vector A is equal to the vector -2, 3. The vector B is equal to 0.7, 1.2. And we want to find A dot B. So all we have to do here is use our standard procedure for dot products. You take the first vector, 2, 3, to dot it with the vector 0.7, 1.2, you're going to get a number out. And what you do is you multiply -2 times 0.7, which is -1.4. And then you multiply 3 times 1.2, which is going to give you 3.6. And we add that to the first number we got, so 3.6. And then we add those two together, what do we get? 2.2. And that's it. So number 3 is pretty much the same way. Let me do number 5. So for number 5, you have two three-dimensional vectors. So we have the vector A, which is the vector 4, 1, 1/4. And the vector B, which is the vector 6, -3, -8. All right, so same thing, I want to find the dot product. So the dot product of these two vectors is equal to, we're going to multiply 4 times 6, which is going to give us 24. We're going to add to that what we get when we multiply 1 times -3, which is -3. So I'm adding a negative. I could have just written subtraction. And then 1/4 times -8 is -2. So I'm going to be adding -2. And then, so this is 24, take away 3, that's 21. Take away 2, this is 19. Okay, that was number 5. Let me see what's next. Let's look at 6. I'll go a little faster with 6. I'm not going to write down everything the way they are, or the way it, rewrite or write A and B. I'm just going to write, we're going to be doing the dot product for number 6. We're going to be dotting the vector P, -P, 2P, and we're dotting it with the vector 2Q, Q, -Q. So when we dot these two together, we get P times 2Q, which is 2PQ, plus -P times Q, which is, I'll change it to minus PQ. And then 2P times -Q is minus 2PQ. And then we clean this up. These are all like terms. They're all PQ, P times Q. So these two cancel actually. And all you're left with is -P times Q. All right, number 8. Let's look at 8. I'm skipping 7. So you need to first be able to, on number 8, convert this I hat, J hat, K hat notation. So they give you the vector A is 3I plus 2J minus K. And they give you the vector B is equal to 4I plus 5K. So convert A over first. This is the vector, we just look at the numbers in front of I, J, K, so 3, 2, -1. And B, this vector is the vector 4. And since there's nothing in front of the J, there is no J, there's a 0 there, and then 5. And so we can now take the dot product. So A dot B will be equal to, we're going to multiply 3 times 4, which is 12. Then add to that 2 times 0, which is 0. Then -1 times 5, which is -5. And that gives us 7. All right, moving along. Let's look at number 9. So number 9, we're told that the magnitude of the vector A is 6. we're given that the magnitude of the vector b is 5. And we're given that the angle between these, I'm going to call it theta, is 2 pi over 3. And we're asked to find the dot product. So. Come to the door. Okay, so to do this problem, we're going to use the fact that A dot B is also the magnitude of A times magnitude of B times cosine of the angle between the two vectors. So if we're given the vectors in the component form, right? So with the angled brackets and we get the components, we do what we did in the previous problems. But if instead we have the magnitudes, the lengths of the vectors and the angle between them, then there's also a way we can compute the dot product using this formula. Oops, that's supposed to be B. All right, so this will be pretty clean. It's just going to be the magnitude of A, which we know is 6, times magnitude of B, which we know is 5, and then cosine of 2 pi over 3. Now this is 30. And then let's talk about cosine of 2 pi over 3. And just go back to your unit circle. You know, where is 2 pi over 3? So here's pi over 3 up here. All right, that's going to be what, 60 degrees? And then 2 pi over 3 is right here. And when you say cosine of 2 pi over 3, you're looking for the x-coordinate here. The x-coordinate there is -1/2. Remember, the y-coordinate's root 3 over 2. So we're going to use -1/2. So it's this times -1/2, which is going to be 15, -15. And that was number 9. Number 10 is done the same way, except that the angle is 45 degrees, so yeah, I'll let you mess with that one. All right, let's look at 11. 11's somewhat interesting. So 11, it says if u is a unit vector, so they're telling you that u is a unit vector. That means the length of u is 1. So you're given that. They want you to find u dot v and then find u dot w. And they give you a picture. All right, so here's a picture. They give you this triangular shape, this. They give you these little dash marks like this. They tell you this is U, they tell you this is V, they tell you this is W right here. And U is the vector going from here to here, so that's U. And then W is the vector going from here to here, so I'm putting an arrow like that. And then V is the vector that goes from the top down to the bottom. So I hope you can see those arrows. I'll kind of exaggerate them a little bit. All right, there's U, there's V, there's W. Well, one thing we should notice is that if they have these little dashes on the sides, that means this is an equilateral triangle, which means all the lengths of the vectors are the same. So that means that the magnitude of V is also 1, and the magnitude of W is also 1. So that's good to know. And if we want to find U dot V, and we know the magnitudes of each of the vectors, 1 and 1, I can use, it might make sense for us to use this formula, cosine theta, where theta is the angle between the two vectors. So coming up here and looking at u and looking at v, okay, if we attach their tails together like this, we're just trying to figure out what this angle is. Well, that angle is pretty easy because this is an equilateral triangle. That should be 60 degrees. So we should get 1 times cosine of 60 degrees. Cosine of 60 degrees, back to that unit circle. 60 degrees is up here. Cosine is the x-coordinate, which is 1/2. So this should just be 1 times 1 times 1/2, which is 1/2. So u dot v is 1/2. And now we need to look at the next one, which would be trying to find u dot w. So let's see what u dot w looks like. So u dot w should be the magnitude of u times the magnitude of w times cosine, I'm going to say, of beta, where beta is the angle between them. So theta was here, right? So now we're going to look at u and w, and this is a little bit tricky, all right? Because before you can talk about the angle between the two vectors, you have to attach their tails together. So this vector u, the tail's up here, the vector w, the tail's back here. So I need to slide u down like this in order to be able to talk about the angle. So imagine that this is w. I'd slide u down like this. U would go like this. And we're trying to find this angle here, which we'll call beta. Now, extending this up like this, we know that that created that triangle. We know that this is 60 degrees. And if that's 60 degrees, then a full rotation, okay, this way is 180. That means this beta would have to be 120. So the angle between u and w is actually 120, not 60. So be careful with that here. The direction of the arrows is going to dictate that and where the tails are. So going back to this formula right here, I know that the magnitude of u was 1 times the magnitude of w, which is 1, and then cosine of 120 degrees. And to go, you can look at your unit circle. This is going to be -1/2. So the answer here is -1/2. Cosine of 120 is -1/2. All right, let's look at 13. I think I'll do, there's part A and part B. Maybe I'll do just part A. Let me do it first and see if that's enough. So for 13, part A, show that I dot j equals j dot k equals k dot I, oops, equals 0. So you're going to try and show that I hat j hat dot j hat equals 0, that j hat dot k hat is equal to 0, and k hat dot I hat is equal to 0. So let's start with this first one. I hat, by definition, is vector 1, 0, 0. I'm going to dot that with j hat, which is 0, 1, 0. All right, so I'm just doing this one right here. And if I dot those, I do 1 times 0, which is 0, plus I do 0 times 1, which is 0, and I do 0 times 0, which is 0, and that's 0. So far it checks. The first one's true. Now let's do j hat dot k hat. So j hat is 0, 1, 0, dotting that with k hat. which is going to be 0, 0, 1. And when I dot, 0 times 0 is 0, plus 1 times 0, which is 0, plus 0 times 1, which is 0, that checks. And then k hat dot I hat would be 0, 0, 1, dotted with I hat, which is 1, 0, 0. And therefore, you do this, you'll get 0 also. All right, not bad. Okay, so let's look at part B. Part B says to show that I hat dot I hat equals j hat dot j hat equals k hat dot k hat equals 1. So I'm just going to do one of these. I'm just going to do this one right here. I'm going to show that that's equal to 1. So if I take I hat, that's 1, 0, 0. I dot it with itself 1, 0, 0. Then I get 1 times 1 is 1, plus, and then 0 times 0, 0, 0 times 0, 0, so plus 0, that equals 1, that checks. And you can do the rest. All right, let's look at 14. 14 looks like a word problem. It says, a street vendor sells A hamburgers. So A is the number of hamburgers that are sold. B hot dogs. And C is the number of soft drinks. I'm just going to put number of drinks. He charges $2 for a hamburger. I'm just going to put an arrow here. $2 each. Charges $1.50 for a hot dog. And charges $1 for a drink. If the vector A equals ABC, and the vector P equals 2, 1.5, 1. What is A dot P? So recognize that ABC are the number of hamburgers, hot dogs, and drinks respectively, and 2, 1.51 are the costs corresponding to the hamburger, hot dog, and drink. So if I dot these two vectors together, I'm going to do A times 2, which is 2A. Do B times 1.5 and add it, so 1.5B. Plus C times 1, which is C. And what would that quantity represent? What would A dot P mean to us? This would be the total revenue for the person selling these things, right? So if somebody tells me how many hamburgers, hot dogs, and drinks I sold, then that formula right there would give me all the money that I brought in. So this would be the revenue. The money that you bring in. It's kind of an interesting, all they're trying to do is get you to see that you can take this problem and that the dot product can actually represent something here rather than just some arbitrary number that comes out at the end. All right, number 15. Find the angles between these vectors. Was that 12? Hold on. That was 14, sorry, yeah, I think I forgot to change it. That was supposed to be 14. So 15 is what I'm working on now. got some vectors here. You've got A, the vector 4, 3. B is the vector 2, 1, 2, negative 1. And we're supposed to find the angle between these two vectors. All right, so I'm going to need my calculator for this. All right, clear everything out. All right, so we have a formula, right? We have a formula for this. The angle between two vectors, right? If we're given two vectors A and let's say another vector B, the angle between them is equal to cosine inverse, or the arc cosine, of A dot B divided by the magnitude of A times the magnitude of B. So that's our formula. So I'm just going to see what I need here. I'm going to need to do A dot B. Okay, I'm going to figure that. But I'm also going to need the length of A and the length of B. So let me work on those right now. The length of A is the square root of the sum of the square of the component. So I'm going to square 4, get 16. I'm going to square 3, get 9. Add these together. Square root of 25 is 5. So the length of A is 5. The length of B is the square root of, let's see, 2 squared, 4. Negative 1 squared is 1, so root 5. And let's figure out what A dot B is. So multiply the components. 4 times 2 is 8. Add to that this, but that's negative 3, so subtract 3, we get 5. So here's what we've got. In this formula, theta will be equal to arc cosine of A dot B, which was 5, over magnitude of A, which was 5, times magnitude of B, which was root 5, which is the same as arc cosine of 1 over root 5. So I'll go ahead and do that on my calculator. 1 divided by, 1 divided by the square root of 5, and then take the inverse cosine of that. I'm getting theta is, and I'm in radians here, 1.107 radians, which if we convert that to degrees, we multiply by 180, we divide by pi, and we should get 63.4 degrees. All right, that's it. Now, I think the rest of these, number 16 and 17, are pretty much the same, except they're three-dimensional vectors. I'll let you mess with that. I think you can handle that. I think 18's worth looking at. Because when I do 18, you'll know how to do, I'll have to do the same thing I did for 16 and 17. So 18 should be enough to cover that material. So it says find correct to the nearest degree the three angles of this triangle. So they give you a triangle and they give you vertices. So you don't need to do this, but I'm just going to do it for fun. Try and draw this. You go out, let's see, 1, 0, negative 1. That's A. 3, 1, 2, 3, negative 2. and then 0, that's here, and then 1, 3, coming this way. So maybe like 1, 2, 3, and then up 3, somewhere around there. Okay, so we've got these 3 points in 3-dimensional space. I'm only doing this just to help you see it. So this point here is in the first octet. This is C. A, this was B. Okay, B was flat. It was on the XY plane because we never went anywhere on Z. All right, that's good enough. So there are 3 points in space. We connect them with lines. When we do that, we create a triangle. So it's important to note that these are points in 3-dimensional space. These are not vectors. And we're asked to find the angles of this triangle. And to do that would be very difficult without the dot product. So I'm going to erase everything here. And just draw my triangle like this. A, B, and C. And what I'm going to do is I'm going to create some vectors. So let's try and get this angle right here first, which we'll call little a. All right. To get little a, we're going to need to get 2 vectors. We're going to need to get the vector going from here to here. That's the vector that's going from A to B. And then we're going to need to get the vector that goes from here to here. That's the vector AC. And if I can get those 2 vectors, then I can talk about the angle between them. So let's go ahead and write down what those are. The vector from A to B, we use the points here, right? I'm going to take all the B coordinates of the point and subtract all the A coordinates because I'm going from A to B. So 3 minus 1 is 2. That's a vector, 2. Negative 2 minus 0 is negative 2. And 0 minus negative 1 is 1. So this vector AB, right, is the vector 2, negative 2, 1. Then the vector from A to C, I'm going to do the C coordinates and subtract the A coordinates. So the vector from A to C is, let's see, 1. Take away 1, you get 0. 3, take away 0, you get 3. And then 3, take away negative 1, you get 4. So this is the vector 0, 3, 4. So if I want to now know the angle A, I'm going to use that inverse cosine formula. The angle A in this problem will be equal to arc cosine of this vector dotted with this vector, so AB dotted with AC, over the magnitude of this vector, AB, times the magnitude of this vector, AC. So let's do it. I need to figure out what AB, the vector AB dotted with vector AC is. I'll figure that out in a second. I need the magnitudes also. So let me get the magnitudes, and I think I'll do the magnitudes right here. The magnitude AB is going to be these components squared and then square root. So square root of 2 squared is 4 plus negative 2 squared is 4, and then 1 squared is 1. So you get square root of 9, which is 3. And then the magnitude of AC, which is this vector, we need that, is square root of this squared plus this squared plus this squared. So we have 0 plus 9 plus 16. That's square root of 25, that's 5. And then we need the dot product. So we take AB, B, and dot it with AC. We get, now we're just multiplying 2 times 0, 0. Negative 2 times 3 is negative 6. 1 times 4 is 4. So this is negative 2. And so now I think we have everything we need. The angle A, will be equal to arc cosine of AB dotted with AC, which we said was negative 2, over the magnitude of AB, which was 3, times the magnitude of AC, which was 5. And so this is cosine inverse of 2/15. So I get my calculator out again. 2/15, I take the inverse cosine of that, and I get that this angle A is equal to 1.437 radians. And did they want it in degrees? Yes, in degrees. So times 180 divided by pi is 82.34 degrees. And they want it to the nearest degree, so I'm thinking they're going to want you to put 82 degrees. Let's see, what number was this? This was number 18. Oh, you know what? I know what happened. I forgot my negative. Oops, negative. Clear that. Negative 2 up here. So negative 2 divided by 15, arc cosine. Yeah, apologies. This should be little things, 1.70 radians. And then times 180 divided by pi. All right, that's better. 97.66 degrees, which is approximately 98 degrees. So that's one of the angles. Now you have to go get another one. Once you get 2 of them, you can find the third one because they all have to add up to be 180. But to do, let's say, this angle B, you'd have to start things over, I guess. Well, not really, but you would need 2 new vectors. It would be the vector going from here to here, so you'd need BC, and you need to be working with the vector going from here to here, which would be the angle BA. So the vector BA would be easy to get because it's just the opposite of this one. It's pointing in the opposite direction, so it's just negative 2, positive 2, negative 1. But you need to get BC, and then you do the whole thing again. So I'm not going to do that. I'm just going to tell you what the other angles are. The other angles of this triangle should be 54 degrees and 28 degrees. So once you go through and work this again, you should get 54 degrees and 28 degrees. And that'll be it. How are we doing here? Number 19. All right, so for number 19, it asks whether these vectors are orthogonal, parallel, or neither. So let's say they give you the vector A. There's different parts to this. I'm doing part A right now. A is negative 5, 3, and 7. And then vector B is the vector 6, negative 8, and 2. So the question is, are these orthogonal? Are they parallel? Or neither? So what does it mean to be orthogonal? Orthogonal means that A dot B would have to be 0. Parallel would mean that A must be some scalar multiple, C, times the vector B. So there has to be a way to just multiply B by a number, the vector B by a number, scale it, and get A. And then neither would be if those two things are not true. So let's look at the orthogonal first. Are these orthogonal? So what's A dot B? Well, this is going to be negative 5 times 6 is negative 30, plus 3 times negative 8, which is going to give me negative 24. And then 7 times 2 is 14. I think that that's obvious. That's not equal to 0. So they are not orthogonal. Are they parallel? Well, what we need to do is we need to see if there's a way to turn negative 5, multiply it by something to get 6. Well, what do you have to multiply negative 5 by? Multiply it by something, I'm going to call it C, to get 6. Well, C then would have to be negative 6/5. So if I multiply negative 5 times negative 6/5, I would get positive 6. But that C has to work for every one of these. So if I multiply the 3 by that negative 6/5, am I going to get negative 8? That's the question. So let's try it. Negative 18 over 5, that's not negative 8. No, that's not going to work. So there's no way to just multiply this vector, scale it by a number, and get that vector. So they're not parallel. And since they're not orthogonal and they're not parallel, the answer is that they're neither. Okay, so how about part B? The vector 4, 6, and negative 3, 2. Well, you know what? I think that that's too easy. I mean, you can work that yourself. You get the idea of what you're supposed to be doing here. I think 20 works the same way. And I'm looking at my time here, how much time I've got left. I think 19 you can do the rest, and 20 you can do. Let me do one where they're parallel so you can see parallel. How about 19D? So 19D, you're given two vectors. A is the vector, I'm going to convert it right now. It's 2, 6, negative 4. B is the vector negative 3, negative 9, 6. So do a quick dot product, okay, to see if they're orthogonal. So A dot B, so I get negative 6, I get negative 54, negative 24. There's no way that's 0. So they're not orthogonal. To see if they're parallel, let me first try and turn 2 into negative 3. So if I'm going to multiply 2 by some scalar to get negative 3, then that scalar must be negative 3/2, just dividing by 2. So that's how I can turn 2 into negative 3. So the question is, am I going to be able to turn 6 into negative 9 if I multiply by the same scalar, negative 3/2? And you can see here that if you do this, right, you get negative 18 over 2, and that is negative 9, and that works. So I know I'm going to be able to turn the 6 into a negative 9, and then I need to check, can I turn the negative 4 into 6 also? So by scaling by the same thing, negative 3/2. And check it yourself, that's 12 over 2, that's 6, that works. So they are parallel because they are scalar multiples of one another. In fact, if you take the vector A, right, and you scale it by negative 3/2, you get the vector B. That's what we just said. Take this, multiply it by -3/2, it'll turn into this. You could have also done it the other way around. You could have tried to turn this one into this one. If you did that, you would have gotten this. A is equal to -2/3 B. So just algebraically, if you multiply both sides by the reciprocal here, then that's what you would have needed to go the other direction. So, all right, hope that makes sense. All right, I think I'm going to do a quick stop right now and then come back, pick up the rest of these problems.